make you know the bother with.
Welcome to another step communication, Junior Science Olympiad, the chemistry component of the Junior Science Olympiad. I have a first question with me here, which will be guiding me in the communication. Okay, so I implore you to be attentive. Hold your pen, hold your Bible, and let's see how much of this you can cover within a very short time. Question number one: which among these is not an example of acid? Acid. We have hydrochloric acid (HCl), etonic acid CH3COOH, sulfuric acid H2SO4, nitric acid HNO3, and sodium hydroxide. Now the answer is sodium hydroxide. This one is basic. It's an alkaline. Okay? How do you recognize alkaline? It has this group hydroxyl function. Okay? It has this hydroxyl OH. Any compound attached to a metal, either alkaline metal or alkaline earth metal, okay, attached to this OH, which is hydroxyl. Then it is base. So this one are acid. Now let's talk more about this. This is hydrochloric acid. How do you recognize acid? It must have hydrogen ion. So you can see the hydrogen ion for hydrochloric acid, for sulfuric acid, for nitric acid. Then for this one, this is the hydrogen ion, not this one with H3. Take note of that. So another question you can ask is that what is the basicity? Take note of that, of the following acid. It means the number of replaceable hydrogen atom. For hydrochloric acid, one hydrogen atom. For this one, just one hydrogen atom. This one is in a T group, okay? So it is this. Okay, one hydrogen atom. For sulfuric acid, the basicity is 2. For nitric acid, it is 1. Please take note of that. Now, watch out for basic. Another name for basic is alkaline. Okay? So, any compound like calcium hydroxide, look at this. Calcium hydroxide. All these ones are basic substances. We have acidic one. Don't forget, they can ask you for the basicity. The next question: what household heating fuel also power jet plane? They gave us the following option: coal, firewood, charcoal, kerosene, gas. You remember that kerosene is used as an household heating fuel. Okay? It's also used to power planes, jet planes, kerosene. So the answer is kerosene. Don't forget that. Kerosene. Okay? If you still have time, we look at all the various components of the mixture called crude oil. Okay? Kerosene is one of them. Now, the next question. A molecule of argon is diatomic, ionic, triatomic, monoatomic, cationic. No, the answer is it is monoatomic. Atomic is Ar. Okay? Argon, this is the symbol. It is not, you can't write it as Ar2. No, it is atomic, monoatomic. Oxygen gas or oxygen molecule is O2. So this one is how many atomic? 2 diatomic. This one is what?
2 diatomic.
No, it's diatomic. It has 2 oxygen atoms. There is one that is called ozone. Ozone is O3. This one is tri means 3 atomic. Triatomic, okay?
Yes.
All right. So diatomic, most gaseous substances like hydrogen gas, okay? This one is also chlorine. These are diatomic. They contain 2 atoms of chlorine, and so on and so forth. Please take note of that. Okay, this is chemistry. So let's continue with some other stuff. we have for you. Now, the next question, look at this. They gave you this. They wrote this for you. 6, then they now put CH4. This substance is called methane. Now, any number that comes before a compound like this, we call this stoichiometric ratio. Okay? What I call it? Stoichiometric ratio. Now, if you want to read it, it's an indicator of the number of moles. So this one, you have to know the name, is methane. This one means 6 moles of what? Methane. Methane is a natural gas for cooking at home, okay? So the interpretation they are asking you, so the correct option that they are asking to interpret, how do you pronounce this? It means 6 moles of what? Look at this, if I write this, C6H6. This is benzene. Benzene. It is an aromatic substance. Aromatic. Okay? It has a flagrant smelling. It has a flagrant sweet smelling. Okay? Now, if you want to pronounce this, I wrote a 10 before this benzene. It means how many moles of benzene? 10 moles of benzene. Now, if I ask you again, another thing I ask you is this. How many atoms of carbon is in 6 moles of methane? This 6 multiply, this one that has no number, it means it is 1. So 6 times 1, 6. It means there are 6 carbon atoms. How many atoms of hydrogen do we have here? You multiply this by this. 6 times 4, 24. It means there are 24 hydrogen what? Atoms. Let's come to this benzene. Another thing they can ask you. How many atoms of carbon do we have here? This 10 multiply this 6. 10 times 6.
60.
So there are 60 carbon atoms in 10 molecules in 10 moles of benzene. How many atoms of hydrogen do we have? 10 times 6. We have 60 atoms of what? These are other questions, okay? Don't worry, I'm still going to do some kind of stuff on chemistry that will make us to go deeper. The next question. Convert 15 degrees Celsius in Kelvin. Now, you can convert in degree Kelvin, you can also convert to degree Fahrenheit. It's very easy. Now, the temperature scale, the Celsius one is, the lower physical point of water is 0 degree. This is what?
100.
100. This is for degree Celsius. Now, for Kelvin, for degree Kelvin, it is, the lower is 273. The upper is 373. For degree Fahrenheit, okay, it is 212. It is what? Here, 32. That means all these ones are equivalent. They are the same value. Okay? Now they are asking us to convert 15 degrees Celsius. This is Celsius. So anywhere between 0 and 100, you put 15. They said you should convert it to in what?
Kelvin.
In Kelvin. So in Kelvin, you are looking for this question mark. Is that clear?
Yes.
Now you can use this method, but the very simple method to this is that I will explain this one in a different context. Is that if you are converting from degree Celsius to degree Kelvin, always add this to this. So this 273 to this. So it will be 273 plus what? 15 degree. Okay?
Yes.
Now there's another method I want to teach you. We call it interpolation. Okay, let me just teach you that. Because they can also ask you to convert it to what? Degree Fahrenheit. This one is degree Fahrenheit. These are the way in which you can express the temperature readings of any object. Now, since it's between degree Celsius and degree Kelvin, you use interpolation method. 100 minus 15, look at it, 100 minus what?
15.
Divided by 15 minus what?
0. 15
minus, I'm interpolating, minus 0. Now you have to go the same direction here. This will be what? It will be multiplied to what? 373 minus x for what? X minus 273. So this is x minus 273 equals multiply. and find your x. You must be very good in mathematics. This is mathematics. But the short form to this is this. Just add this to 273. You have the answer in degree what? Okay. So 273 plus 15. Okay, 8828. Is it there? Yes, it's one of the options given to us. Now let's just leave that and move. The next question, okay. Let's see the next question. You have to be smart. This is for smart students. Olympiad is for smart students. Okay? Which of the following is not a unit of pressure? First of all, another name for pressure is stress. So I can also ask you which of the following is not a unit of what?
Stress.
Of stress or pressure. Here they say atmosphere, millimeter mercury. So let me just list them. We have atmosphere. We have millimeter mercury. Hg is mercury. We have Newton per meter squared. We have Pascal. Then we have Tor. T-O-R. These are the various ways in which you can express pressure. So here, they said atmosphere, millimeter mercury, Newton per meter squared, Pascal, Fahrenheit. No, Fahrenheit is not part of it. So that one is not. Fahrenheit is for temperature. For temperature. Now let's move to the next one. A mixture that is neither a solution nor a suspension is termed colloidal. 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 A mixture that is neither what? A solution nor a suspension. Then it's from the colloids. Colloidal. Okay? Don't let us waste time on that. Now the next question. The hybridization of carbon. I want to spend time on this. Listen to this. The hybridization of carbon atoms in alkanes, hybridization. That is the missing of orbital. Okay? Atomic orbital. Now that's what we call hydrocarbon. There are some organic compounds that are called what? From the name, hydrogen and what? Carbon. There are two major types. We have the aliphatic. Because I saw this a lot in this Olympiad junior class, and then we need to quickly address it. So I want to stay more on this for some time. Okay? Then we have aromatic. Now this aliphatic is of three types. We have alkanes. Okay, I'm putting the camera here. Then we have alkanes. Now, this aromatic compound, the beginning is benzene. I've mentioned benzene today. Benzene is C6H what? Is the family of aromatic compound. All begin from what? Benzene. Take note of that, you can ask you that. There are other, like from this, if you remove one hydrogen atom, that will be C6H what? 5. Then you now replace it with what? Hydrogen. OH. Then we call this one, it becomes phenol. It becomes what? Phenol. So it comes from this benzene. The other one, so but the foundation to all aromatic compound is what? Benzene. And what is the chemical formula for benzene?
C6H.
Take note of that. If you remove one hydrogen atom and you replace it with what? OH. Functional group, it becomes what? Phenol. Now benzene has three double bond and 3 single bond. Look at it. 6 carbon. 1, 2, 3, 4, 5, 6. Double, single. Double, single. Oh. Double, then single. Is that not? 1, 2, 3, 4, 5, 6. 6 carbon. Hydrogen. All these are for hydrogen. 6 hydrogen with their attached. Okay? That's one way of doing that. Another way you can do a benzene is to do like this. Then you put a ring structure. So a benzene has a ring structure. You can see that it's circular, so it has a ring structure. All these are the carbon, where you attach the carbon. The carbon are existing here. Then you now attach the hydrogen. Is that clear? Okay, I don't waste much of time. Just take note of this structure. It has how many double bonds? 1, 2, 3. How many single bond? 1, 2, 3. That's enough for your level. Now let's go to the aliphatic. There are 3 types. This is where an analysis question from the Olympiad Junior School past question. So let's look at that. Now this alkanes has a formula like this: CnH2n plus 2. That's alkane, the first one. Alkanes, CnH2n. Then alkynes, CnH2n minus 2. Now let's look at it now. The alkanes and what? The alkynes. Okay? The first is methane. Met means 1. So it means it has 1 carbon atom. Okay? So the first one is methane. You remember we mentioned methane today. This one does not have met. The next one is X. X means 2. Now the formula for this one is CH what?
4. If
you use this formula, and C is 1 carbon. You put 1 there. 2 times 1, 2 plus 2.
4.
That's why you have CH4. Now, alkanes and alkynes do not have there's something like methane or methane. But this one, X means what? 2. So we have ethane. That is C2. You use that formula. 2 times 2, 4 plus 2, 6. That's ethane. Can I write the name? Let me write it. Ethane. C2H what? 6. This one will be ethane. This one is 6, the ethane. Carbon is 2. You use the formula 2 times 2.
4. So
this is the formula. This one is ethane. This alkynes, we have ethane. Carbon is still 2. 2 times 2 minus 2. So H2. Take note of that. The next one is prop. So prop means 3. Okay?
Yes.
So the first one here we have what?
Propane.
Propane is 3. That means C3. Using this formula, look here. 2 times 3 is
6
plus 2.
8.
That means H8. This one is what? Propane. C3. 2 times 3 is 6. This one will be propane. What is this? C3. H what? What is 2 times 3? 6 minus that 4. Propane. Did you see that?
Yeah.
I'm taking you a whole lot of topic on this because I saw question on hydrocarbon. That is very important. So the next one is but. But means 4. So we have butane. You can use that formula to generate it. After but we have pent. From the word pentagon. Pent means what? 5. We have X. Ethane. X means what?
6.
We have het. Ethane. X means what?
7.
We have octane. Oct means what?
8.
We have none. That's what? 9. We have decade. I'll stop here. Dec means what? 10. Now let's look at this. Let's generate for this ethane. For this one to be ethane. For under alkanes it will be ethane. Meaning carbon is how many? 6. So use this formula. 2 times 6, 12 plus 2.
14.
So H14. Did you understand? So you can go on and on. Now let's not go back. So this is very important. You must know alkanes and alkynes. They can form. Let me talk about this. This compound can form long chain. The carbon can be arranged in a long way. Okay.
Yes.
They can be branched. This one I can branch it like this. Is that clear?
Yes.
Do you understand?
Yes.
Then the alkanes can form cycloalkanes. That means the carbon atoms of alkanes, only alkanes, so not alkanes and what? I can arrange it in what? In circular form. Let me demonstrate that for the purpose of this. Let's pick ethane, for example. Ethane. Look, let's what happened when we turn ethane to cycloalkane. Hexane is how many carbon? 6. And it must have single bond, not true. Is that also? Then this one, how many? Hexane is 6 H what? 14. Now let's now see what happened to it when it comes to cycloalkanes. We have 2 hydrogen because for every carbon atom you can only have 1, 2, 3, 4. Do you see that? So how many hydrogen do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then this one here, 11, 12. And how many hydrogen do we have here? It means when alkanes, turn to cycloalkane, how many hydrogen is lost? 2. Take note of that. 2 hydrogen is lost. Now, again, let me still continue with this because of what I'm saying. For alkanes, for example, let's take ethane, 2 carbon. This is the structure. Single bond, all true. So alkanes is associated with single bond. Ethene, 2 carbon. That one must have at least 1 double bond. You can see that the hydrogen is 1, 2, 3, 4. It must not be more than 1. Because carbon is tetravalent. 1, 2, 3, 4. So hydrogen. The alkanes must have at least one what? Double bond. See, this one is double bond. From this now, I will now explain that question to you. You can't go into details because this is a revisional class. For alkanes, I'm taking an example of ethane. Ethane is also 2 carbon, but this one has how many bonds? Triple. This is 1, 2, 3, 4. This is okay? Yes. Now this is it. This one has what? Triple bond. You can see. Take note of this. So this is alkanes, alkanes, using the examples of ethane, and what? Now they are asking us. Let's go back to the hybridization. Now you see. I don't want to go into details, okay? Because I'm not taking this as a holistic topic. We don't have the time for now. But let me just explain to you what happened. You see, there is a missing up of the orbitals from the carbon and hydrogen atoms of any of these compounds that you see. So for alkanes, the one with single bond, it has sp3 orbitals. For the one that is alkanes, it is sp2, and for the alkanes it is ordinary sp. So they are asking you the hybridization of carbon atoms in alkanes is what? sp3. Take note of that. Well, maybe if there is more time for you, we'll be able to explain. But hybridization means the missing of orbitals. These are orbitals. We have the following orbitals: s orbital, p, D, and what? F. This S can contain how many electrons? 2. Add 4 to 2. How many? 6. P can contain 6. Add 4 to 6. 10. D can contain. Add 4 to 10. 14. That is the number of electrons these orbitals in the electronic structure of atom can accommodate. Are you following? I would like to stop here. We'll come for the part 2 of this topic. I'm already sweating. I need to go and take care of myself. Thank you. See you. Go over this very well. Very important.
Down the river we drunk and all of our thumbs went up in the air.